Hi, so we are back at it again with another LeetCode problem. This time it's a valid anagram 242. So what we have to do in this problem is we have given two strings S and T. We have to compare them and check return true if it's an anagram and false otherwise. So the way we approach this problem is firstly, we compare the lengths. So obviously, if the lengths are not matching, then it cannot be an anagram of one another, right? And the way we do this iteratively is first by declaring a hash map because the constant lookup time is really fast compared to arrays or list. So I'll walk you through the code first and then we'll jump into the visual explanation. So what happens is we loop through each character in the string S. We loop through each character in string T, right? So these are the two for loops. So in the first for loop, we are just counting the frequencies of each character that has occurred in S. So for example, if we have uh, if we have anagram as an example, right? So what we do is we check if A is in the hash map. If it's not, then return 0. And if it's present, then return its increment its value by 1. So suppose we have the string anagram anagram, right? And we have our hash map. Right. So initially it's empty. So if the character, right? So we are looping through the string S. So we are checking right now A. So if A is it in the hash map, dot get gets the key of the hash map. So if it is, then return 0. Sorry, if it is, then return its value, and if it's not found, then return its value and increment it by 1. So initially, if there is no key in HashMap, then add that key. So A will be added, and value of 1 will be assigned to it. So this is basically the frequency count, right? Same goes for N1. And now what happens is A is already present in the hash map, right? So what we'll do is it will return its previous value, which was 1, and then it will add 1 to it. So previous value plus 1 to it. So now the new value will become 2. And because HashMap cannot have duplicate keys, it can only have one key. So actually this value will be incremented. It won't add another key to it of A. So the original value will be incremented by 1. And then we keep doing it until we get a counter map essentially. So N A, now G is 1, and then R is also 1, and then A will become 3, and then M will also be 1, right? So we have our hash map right here, and then what we do is we have another hash map. We loop through T this time, and if this key is not found in the hash map, so it will return 0. That means no key has been found, right? So if there is no similar alphabet in letter S, which is also in letter T, then return false, because so what ends up happening is we have another string T, we are looping through it, right? So that's Nagram. Suppose this is not an anagram, right? We take a different string, for example. So let's assume that if this was I, right? Clearly S and T are not anagrams anymore. So we loop through the string T, right? And our first character is N. So if N is found in our hash map, return its value. So 1 will be returned. And because there is a not operator, it will invert the 1. So it will become 0 and it will not execute this false statement, and it will continue here, right? So if N is found, then what we do is we decrement its value by 1, right? So N will be 0 now. So that means we have already checked for N. And this check, what happens is if the N, its value is less than or equal to 0, then delete it from our hash map. So we delete it from our hash map, right? Because it makes sense. We are counting the frequencies, and if the frequency is 0, then we don't want it in our hash map, right? Then we take a look at A, right? A. So our new character is A. So again, we have A in our hash map. So we decrement its value by 1. So this will become 2. Now let's take a look at I. Well, I is not found in our hash map, right? So what ends up happening is this will return 0, and because not of 0 is 1, uh, our function will return false and it will terminate the code, as this is not an anagram. So basically we are comparing two frequency maps of both the strings. Now let's walk through the example where both the strings are anagrams. So let's compare these two strings. So we'll start from N. So N is present and it has value of 1. So we decrement its value to 0. And because it's less than or equal to 0, then we delete it from our hash map, meaning no N is found anymore. Then we take a look at A. So decrement it, but it's still not less than 0. So we keep it in our hash map, right? And then we take a look at G. So decrement it, it's 0, delete it from our hash map. Then we take a look at A. So now it's 2, so we make it 1. It's still not 0, so we keep it in our hash map. R, make it 0 and then delete it from our hash map. Again A, so this time it becomes 0 and we delete it from our hash map. And then the last one is M, so decrement it and delete it from our hash map, right? So this for loop gets executed once. So after comparing those two strings, if we find that all the distinct elements in S and T are the same, then we exit the for loop and return true, meaning we have found that both the strings are anagram of each other. Another quick thing I wanted to mention is we can just write this code in one line by doing this. Return the counter of S, if return true if the counter of S is equal to the counter of T, and return false otherwise. So what this does is it creates a counter map, so basically a hash map for both S and T, and it has all the values. So A is 3, blah blah blah, M is 1, A is 3 here as well, and M is 1, right? And then it compares, are both the keys and the values, are they equal? So if everything is equal in S and T, then obviously it returns true, because this is an anagram. And as a reminder, hash maps cannot have duplicate keys, so that's why this solution works.